Let's look at an example. Determine the shape, center, and spread of the sampling distribution. A population of value has an unknown distribution. So we don't know the shape. The mean is 152.8 and a standard deviation of 41.7. List the givens with the correct symbols. So we have a population and the mean is 152.8. So that's mu equaling 152.8. And again, a population, standard deviation is sigma at 41.7. You take a sample size of n equaling 74. Can you say what the shape of the sampling distribution for the sample mean is? The distribution for the sample mean will be approximately normal, right? So yes, we can assume approximately normal. Because n is greater than or equal to 30. We don't know the distribution. Now if it said normally distributed and this was any value, it would not matter because it was stated it was normally distributed. So just keep that in mind. What is the mean of the sampling distribution of the sample mean when n is equal to 74? So I would refer to the overview sheet. Again, we're on sample mean, x bar. We just did the central limit theorem. We invoked that. The mean of the sample means is equal to mu. So mu of x bar is equal to mu. What's mu? 152.8. So that's the mean of the sampling distribution of the sample mean. Lots of wording going on there, but again, it's just the sample means that we are plotting and then coming up with the new mean and standard deviation from that. Standard deviation of the sampling distribution of the sample mean. So standard deviation of the sample mean is sigma over the square root of n. So sigma is 41.7 over the square root, and n is 74. So if you ever needed to have a non-rounded answer, this is what you would use. Typically, you could just do a rounded answer, 41.7 divided by the square root of 74 equals, make sure you hit equals if you're using your online your computer calculator, 4.85. So you take a sample size of n equaling 30. Can you say what the shape of the sampling distribution for the sample mean is? No, because up here we don't know the distribution, and now n is less than 30. So the population distribution is unknown, and n is less than 30. What would be the mean for this sampling distribution of the sample mean when n is equal to 30? Again, mu of x bar is equal to mu. So it'd still be 152.8. And then the standard deviation of x bar would be sigma over square root of n. So sigma is still 41.7, but your n changed now to 23. So square root of 23. So 41.7 divided by 23, and then do the square root and hit equals. So 8.70. compare the standard deviations. You see the larger you get for the sample size, the smaller it's going to be, because the closer you are to the actual mean. And the last example for this video. Circle the true statements, if there are any, about the sampling and distribution of the sample mean x bar. The distribution is normal regardless of the shape of the population distribution if the sample size n is large enough. That is true. Once n is greater than or equal to 30, it does not matter what the population distribution is. The distribution is normal regardless of the sample size if the population distribution is normal. That's correct. So if the population is normally distributed, the sample will also be normally distributed. And it does not matter what size it is. So for A, n would need to be greater than or equal to 30. And that is, for B, it's saying population distribution is normal. C, the distribution's mean is the same as the population mean. That is true because mu of x bar is equal to mu. The distribution's standard deviation is the same as the population. That is not true. The distribution standard deviation is smaller than the population standard deviation. That is true. Sigma x bar is equal to sigma divided by square root of n. When you divide it by square root of n, that's going to be a smaller number than sigma, right? Because you're dividing it by a number. Hence the reason it is smaller mathematically. Also, if you wanted to look at it a different way for E, we had found sigma x bar as 8.7, right? That's less than our sigma, 41.7. So sigma x bar is less than sigma. So if this was confusing, don't worry about it. Just know that the distribution's standard deviation is smaller than the population standard deviation. This is smaller than the population. This is sample. This is population. So the sample is smaller than the population.